So this is a CNC block machining center where we do all our engine machine work, both racing and streetcar motors. It's a $165,000 tool. What you do is you program this thing, and it actually, you flip the block over to one side, and it comes in and finds the X, Y, and Z coordinates of where the cylinder is, bores the cylinder out, goes down, puts a relief at the bottom up for the head of the stone when you go to hone it, comes up, chamfers the top of the block. The top has no sharp edges to catch the rings when you put it together. And then it moves on to the next one, moves the block. When it's all done, it beeps at you like a dryer when it's done. You come over, you pull a pin, you flip it 90 degrees, you push go again, it bores the other side. It takes about 20 minutes to machine an engine. Now, the reason we bought it wasn't really to save time. Our volume was pretty low. We do a couple motors a week is all we do, maybe 3. The reason we did it was quality control. Modern BMW engines, and not just BMW, Mercedes, Porsche, Audi, they're all doing this now, is a block that's called alusil. Okay, what that means is there's no steel sleeve in it. There's a high content of silicon. I think it's around 33% of silicon. It's basically like making chocolate chip cookies. You actually have the aluminum molten, and you take the silicon, you dump it in, and you stir it, like chocolate chip cookies, and the silicon mixes up in the aluminum. So it's not that there's a coating of silicon. The silicon is impregnated in the entire casting. Okay, and then what happens is after you machine it like this, you actually etch the block, and you etch the aluminum away, and that makes the silicon proud, and then the piston and the rings glide on the silicon coating. Because you etch the aluminum away, you don't etch the silicon. The problem is if you cut this thing at the wrong speed, okay, there's a special diamond bit here, this bit will rip the silicon nodules out. It's like if you went by with a knife and nicked a chocolate chip in a cookie, you pull the chocolate chip out of the cookie.
You have voids?
What's that?
You
have voids, and then you have metal-to-metal contact, and the engine goes bad. We tried to find an American company that could bore the block. So we called people up and say, so, you guys do alusil. What's alusil? You call the next one. We did this for like about 6 months. This is many, many years ago. We couldn't find anybody in the United States that had any experience at doing this. The process is written by Schmidt, who's a supplier to BMW, all the German car companies. The pistons were perfected by Mala. The aluminum is actually American. I think it's Reynolds. It's an American product. That they sold to the Germans because the Americans wouldn't pay the money for the material because it costs more than regular aluminum. They didn't want to spend $20 more a block, so GM puts a steel sleeve inside it, and so does Ford. But the Germans go, wow, lower friction, better sealing, it's only $20? This is what you pay for when you buy the car, right?
You didn't know.
Yeah, so we use this in our race engines as well because it actually seals better. The silicon has lower friction, and the ring sealing is better than a regular crosshatch. The oil is actually stored between the silicon nodules that are left inside the bore. So as you etch normally you have a crosshatch, a hone in a cylinder, and in the grooves of the crosshatch, oil is stored, like little reservoirs. And every time the piston comes up, it drags oil up with it, and that's what stops the piston from sticking to the cylinder wall, those little reservoirs. On this thing, you actually etch the aluminum away, and in between the silicon crystals, the oil resides like it would in the crosshatch. And that's your lubrication. So you're actually riding on oil and silicon. So the process is super, super critical. You have to have the right bit, you have to turn it the right feed speed, rotational line up and down. And then what we do is we run a test every 10th cylinder. We put acetate tape on the bore, and that acetate tape then you put under a microscope. And the acetate tape has silicon crystals stuck to it, and you can see the amount of silicon crystal retaining in the block. That's our quality control. When we first bought the machine, we bought the Schmidt technical information about how to hone it, and then we sat here and played with the honing process on a one block acetate tape microscope until we got it exactly like a stock block. So we bought a brand new block from BMW, put the acetate tape on that, put it in a microscope and say this is what it's supposed to look like if it's done right, and then we practiced that for a couple engines.
You get 10 tries per V10.
Get 10 tries. The good news is we have a bunch of old blocks, worn out racing engines, so we didn't use this, we used old worn out racing engines, so we didn't have to use new blocks. So I took a couple of S62 engines that were bored over a couple times and practiced on those. So they were junk anyway, saved us some money. But the point was to practice the process so that it got down. We think it makes a difference in the longevity of the engine. Now, Mala makes a piston. The piston has a ferrous stand, what they call a ferrous steel coating sprayed on the piston skirt. So they actually acid wash the piston skirt, and they spray iron on it. Okay, the reason they do this is you can't have similar metals. Similar metals want to bond when you rub them together at high speed. So if you rub steel against steel, they weld themselves together. It's called friction welding, actually. It's actually a methodology of welding, of making two parts spin together against each other really fast until they bond. It doesn't make any welding rod. So you never want to run two parts of a similar metal high speed against each other, or they melt into one because their molecular structure is similar, and they want to bond. They want to fuse, okay? So you normally would have an iron bore and an aluminum piston, but now that you have an aluminum piston, aluminum bore, you have to have an iron piston. You have to switch them. Well, you don't want an iron piston because it weighs too much. So you do is you make an aluminum piston, you spray iron coating on it. And the board thinks it's iron when it's aluminum. That's the secret to the process. We only find one piston manufacturer in the world that knew how to do the coating, and that was Mala, because Mala made the original equipment pistons for all these engines. So we went to Germany and bought pistons. Okay, again, twice as much pistons as we could buy from Aries or JE or some of the United States. But the quality of the piston is really good, and we know the coating's right, and we're not going to get bit, going down the road later on. So, part of the reason we can offer the 40 or 50,000 mile warranty is we do this kind of research, we buy these kinds of machines, try and mitigate our costs. If you just rush to market with something and you don't do that research, but you go ahead and give the warranty, you're going to bankrupt yourselves in warranty claims. So our goal is not to have any warranty claims. It doesn't ever work out that way, but that's the goal. Our warranty run rate is about 2.5%, 3% of revenue. So we do have warranty costs, but it's actually fairly low. It's actually lower than BMW's. So you also see it's almost always the market last. Everybody comes out with something before us. Okay. The reason being is we're doing this kind of research when everybody else is selling.
Hurry up, get a product made, hurry up, get it out.
Yeah, I mean, look, we'd love to get the market first. You gain market share that way. It's good for business. I mean, we're businessmen. We understand that, but we also don't want to ruin our reputation when something isn't right. We also don't have to pay for it all when it isn't right. When you're paying for things for 4 years and 50,000 miles, including consequential damages, because we covered things downstream that break too, right? It makes you a lot more diligent. It makes you a lot more responsible. You have to be if you want to survive. So this is a CNC honing machine over here, and then we have surface machines, computerized balancers, magnafluxers. So we have our whole machine shop inside the building, so we have to farm anything out to anyone.
Tell us about your third member, your rear ends right there. I ordered one for the E60 up there.
Yeah. So this
We
we
put
do.
it next week.
Oh, great. So we do differentials, rebuild them over here. We have a couple of guys put differentials together all day long.